Okay, we're going to look at here the difference of perfect squares. Let's recall how to use FOIL here, okay? Because this is kind of what it's based on. If you guys remember, we got FOIL here. I already set this up for our FOIL box. So we're going to multiply our first rows together and columns. Multiply all your rows and columns here by FOIL. This is our FOIL method, and we get a times a. What does that give us? That's a squared. Then a times negative b is negative ab. And then b times a, well, b times a or a times b gives you what? ab. And then b times the negative b is a negative b squared. So what happens with this now is we'll say a squared minus ab plus ab minus b squared. You guys know what happens right here with these terms? They cancel, right? Remember, this is FOIL. First, outer, inner, and last. They cancel. The O9 terms cancel. We end up with a squared minus b squared. So let's put this right up here. This is a squared minus b squared. Now what that does for us is the following. Remember, factoring here. Let's go back to these statements. This product is equivalent to this difference. And the bottom is known as the difference of perfect squares. It's known because you have a difference, and what we're gonna find out today is that these terms that we're looking at right here, right? A squared and b squared are called perfect squares. So anything that is raised to the second power can be thought of as a perfect square. So this is called the difference of perfect squares formula. Okay, we write it down typically this way. You write it down here in reverse, that a squared minus b squared difference. Here's the difference. That's my word difference.
Equal?
Yep, perfect square, perfect square. Difference of perfect squares is a plus b times a minus b. So we're going to have to deduce some perfect squares. Okay, so anything that looks like this, that difference of perfect squares, can be factored as this particular product over here. We'll write this in blue. Okay, so this is what we're looking at. So for example, if we said they gave us something like this, they said, okay, question 1 on the homework is x squared minus 4. Now, believe it or not, they're going to want us to factor these, and how you factor these is really by considering what perfect squares are, and we have to know that. So let's kind of give you an idea of what these perfect squares are, right? Let me start to generate this idea behind a perfect square. I'm going to put a triangle here, right? This triangle is thought of as my base for the exponential. Here's the base. If I take a base and then I raise it to the second power, okay, what you have here, this is known as a perfect square. So we're going to start simple and say, take the number 1, and 1 to the second power is 1 times 1, which is what? 1. You want to know what we call this particular number over here? This 1? This 1 is a perfect square. Okay? Because 1 squared is the value 1. So everything on the right is known as a perfect square. Everything on the left is not. It's the base. So now go to the number 2. And I take 2 to the second power, and I say, okay, 2 times 2 is what number? Is 4. Which is the perfect square? 2 or 4? Anything that looks like this? 2 squared, which is 4, that's my perfect square. Okay, now 3. Let's square 3. 3 squared is 3 times 3, which is 9. Which number is the perfect square? Is it 3 or is it 9? 3 squared is a perfect square. 3 squared is the value 9. So I have to know this list of numbers. 1, 4, 9. These are perfect squares. I would recommend, for the weekend, you guys go home and you generate this list, because you look at this list not just in Math 115, the next class as well, Math 125. So you can see that list over and over again. The perfect square list.
Isn't 9 3 times 3?
It is.
So isn't that 3 cubed?
No, 3 times 3 is 3 to the second power. 4 to the second power, right? This is a perfect square. What's the value? So that means 16 is a what? Perfect square. Let's take some other numbers like 5, right? 5 squared is 5 times 5. Guess what? 5 squared is a perfect square. And what's the value of 5 squared? 25. That means 25 is a perfect square. So we could generate this list, and I do. Let's go to 6, 7, 8. We get what? 6 squared, which is 6 times 6. 7 squared, which is 7 times 7. 8 squared, which is 8 times 8. And let's go through this list here. What is 6 times 6? Okay, 7 times 7. 8 times 8. 64. Let's continue. Let's go to 9, 10, maybe 11, and 12. Let's go down to there. 9 squared is 9 times 9. 10 squared, 10 times 10. 11 squared, that's 11 times 11. 12 squared, 12 times 12. So what's 9 times 9? 81. 10 times 10? 100. 11 times 11? 121. What's 12 times 12? Now the good news is 6 squared, which is 36, perfect square. 7 squared, which is 49, perfect square. 8 squared is 64, perfect squares. 9 squared, which is 81, perfect squares. 10 squared, which is 100, perfect squares. 11 squared, which is 121, perfect squares. 12 squared, which is 144. All these numbers are perfect what? Squares. Now, I want to notate another important thing we have to remember. What is the base for 1 squared?
1.
Good. I'm going to put that in red. My base here is 1. What's the base for 2 squared? 2. What's the base for 3 squared? 4 squared. 5 squared. What's the base? That's an exponential. That's my base. 6 squared. 7 squared. 8 squared. 9 squared. 10 squared. What's the base? Is that 10? What's the base for 11 squared? 11. And 12 squared. Remember, all of these numbers here, this is the base. 11, 12, 11, 10, 9, 8, 7. Those are all the bases. 6, 5, 4, 3, 2, and 1. So when we deal with this formula here called the difference of perfect squares, we have to consider not just a perfect square, but what the base is. Because if you really take a closer look, A is a base, isn't it? B is a base, isn't it? So we have to consider those. So we're almost ready to factor this. We just have to take a look at some additional perfect squares. So let me actually keep this here. Let's do this again still. Base to the second power. Let's plug in for my base. Let's let x be a base. If x is a base now, you know what x squared is? What is x? These are my perfect what? I'll write it here. Let's write it in purple. These are my perfect what? Squares. So x squared is a perfect what? Square. Let's plug in x squared. Let's take x squared to the second power. You guys are taking algebra. What happens when you raise a power to a power here? You keep the base, and what's 2 times 2? You know what that means? X to the 4th power is a perfect square. Isn't that amazing? What's the base? X squared. What's the base for the prior? Is x. Remember, this here is always your what? That's your base. Let's see if we can do some more. What if y is the base? What is y squared called? Perfect square. Good. Okay. What if z was a base? What is z squared called? Perfect square. What if I said to you, we can take 2x as a base, and if I square this 2x by using some algebra, right, I'm going to use some properties of exponents. Could you guys tell me, didn't you guys have a test on this 2x to the second power? Do you guys know why you had that on the test? This is 2 squared times x squared, which is 4x squared. What is 4x squared known as? A perfect what? Square. So let's generate these. Let's take now 3x. What do we do with that? Take 3x, raise it to the second power. We're going to use our properties here, which is 3 squared x squared, which gives us 9x squared. What is 9x squared known as? A perfect square. Do you guys start to see the pattern here with this? Okay. What are the bases? Let's see the bases. Y is a base. Z is a base. 2x is a base. 3x is a base. This is where all my bases are. Okay? Should we do some more? Is that easy or is that hard? All right, let's see. Let's try this out. What if they gave you 4y? What's 4y to the second power? 4 squared y squared, which is 16y squared. Is that true? Okay, my perfect square is actually going to be the 16y squared. What's the base? 4y. What if I plug in a 5y? I have a base for 5y, and I square my 5y. 5 squared, y squared. What is this? That's 25y squared. 25y squared is it a base or is it a perfect square? Okay. What's the base? 5y. And it doesn't matter. I can even plug in here, for example, a 6x squared, and I take this 6x squared and I square it using my properties. That's 6 squared x to the 4th, because I multiply the powers. That's 36x to the what? 4th power. So now, again, 36x to the 4th power, that's a perfect square. And what's my base? 6x squared.
What does the number represent? The size of the square?
Which number?
The one
In front?
The 36.
Oh, 36? You know, it's just, it's what you get when you square 6. 6 times 6 is 36. It's actually, if you notice, if you look closely, isn't 36 a perfect square and x to the 4th a perfect square? 25 a perfect square, y squared a perfect square? 16 and y squared, 9 and x squared, 4 and x squared. In other words, they're all perfect squares we're generating. So what you need to really know is, and let's separate these, but they're not really separate. You need to know 2 things. The value or the expression, if it involves a letter. That's a perfect square. And you also need to know the what? The base. So I actually tell students in 115 and 125. Go home and generate these lists, put it on your refrigerator, even if you have to do it every day, because you want to come to recognize perfect squares. Like you want to say, oh, I know 4 is a perfect square. I know 25 is a perfect square. So is 16, 49. All of these numbers in purple are perfect squares. So you want to know what those numbers are. Even the letters, like x squared, x to the 4th, even x to the 6th. I can take here, and let's sneak it in.
What if it's an odd number?
X to the 3rd power. Let's find that out. X to the 3rd power to the 2nd power gives you x to the 6th. What that means is x to the 6th is a perfect square. My base, though, is x to the 3rd. So it doesn't matter what you put in there. You can even put a person. If you square the person, they're known as a what? A perfect square. What's the base? That person. So anything you put in, square it, is called a perfect square. So you may say to me, well, how does that work with my homework when I have to factor the difference of 2 perfect squares? Well, how do I know, by the way, x squared is a perfect square? Isn't it on my list? Isn't it right here? It's a perfect square. So, okay. Perfect square. How do I know 4 is a perfect square as well? Well, it's back on my what? It's on my list. It's right here as well. How do you factor the difference of perfect squares? This is what you do. You're going to use the difference of perfect square formula. So I have x squared minus 4. Remember, this is 4 is written as 2 to the what? 2nd power. We did it right here. What were the bases? Remember the bases? We said my base here is 2, my base here is x. So you want to know what we can do? We can write this as x, 2, x, and 2. My 2 bases. Remember this? Here, 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 and here. X, and 2, and 2. We just have to be careful about the signs. What are the signs going to be? Plus and what? Minus. They're opposite. So what you guys have here is you factored the difference of 2 perfect squares. So you need to know 2 things. What's a perfect square? And what is the base? If you know those 2 things, you can factor by this formula. Okay, anybody have any questions on that? It's based on you having knowledge of perfect squares. You got to know that list. So make sure you generate it for yourself about 2, 3, 4, maybe 5 times. Put it in the refrigerator. The good news is if you know perfect squares, you get to use it in 115 and 125. You get to use it in the next class too. Okay, so let's look at the next example. We know we did this one already. Okay, let's say this is going to be x plus 2, x minus 2. You guys can put that over here. You put it down, thank you. You can go to me. I'll put it over here. All right, let's look at the second question now, or the third question here. They're going to give us, again, this is now x squared minus what? 25. Okay. Well, first of all, I have a difference. Subtraction. Do I have perfect squares? Is x squared a perfect square? It was in the first problem. Is 25 a perfect square? How do we know? 25 is on our list. Here it is, our perfect square list. Okay, so how do we factor this? We have to find what the bases are. For x squared, what's the base? X. For 25, isn't that 5 squared? What's the base here? Is that 5? Let's put 5 and 5. And it's, what's the signs? Plus and what? Minus. There you are. Okay, you factored the difference of perfect what? Squares. X squared minus 49. Let's check. I got a difference. I got a perfect square. That's x squared. Is 49 another perfect square? Is that on the list? Let's see. Yep, perfect square. Okay. The base is 7. So I'm going to use that. X, my base is 7. 7 and 7. Don't forget. Plus and minus. You're done. Number 7. X squared minus 100. Okay. Notice I have a difference. And then I have x squared, a perfect square. Is 100 a perfect square? How do we know? Let's go back. Let's look in the list. 10 squared? Yep. What's the base here? Isn't the base, what's the base going to be? Let's get this out of the way. The base is going to be, looks like 10. Okay. X, 10, 10, plus, minus. Number 9, x squared minus what? 81. Okay. Difference, and then perfect square. Is 81 a perfect square? Let's go back and check. Oh, looks like it is. What's the base? The base is 9, is that right? Okay. So, x and x, 9 and 9, plus, minus. Okay, you okay with this? Number 11 is x squared minus 1. So let's check. There's a difference. And then you have what? Perfect square? Perfect square. How do I know that the number 1 is a perfect square? Go back to your list. Oh, you know what? 1 is on the list. It's a perfect square. So, the base here is 1. X, 1, and 1. Don't forget to write your signs that are plus and minus. 13. Let's see how sneaky this is. 9 minus x squared. Let's see if you guys can figure this out. Do we have a difference? There's subtraction. That's a difference. What do we have to check now? Is 9 a perfect square? Yes. How do we know 9's a perfect square? Because it's on our what? It's on our list right here. 9. 9's a perfect square. What was the base? 3. So I'm going to put what? 3 and 3. Why did I put the 3 first? Because the 9's first. Good job. X squared is a perfect square. Is that right? Isn't that a perfect square? So what's the base? X and X. What are the signs? Plus and what? And minus. There you go. Okay. So you have to have knowledge of that list. Knowledge of the list. All right, number 15 is 16 minus x squared. And I got my subtraction sign here. That's a difference, okay. And then we have x squared. I know is a perfect square. Is 16 a perfect square? Well, let's check. Sure enough, we know that, right? The number 16 is a perfect square. What was my base, though?
4.
All right, that's a 4. Oops. So, what do I put first? Why 4 first? 16 came first. Good. X and X. What are the signs? Plus, minus. Okay. Number 17. X squared minus y squared. Okay, well, first of all, I'm going to notice that I have a difference. And then I'm going to notice another thing. X squared is a perfect square. I've seen it enough. Is y squared a perfect square? How do you know? Is it on the list? It sure it is. There it is. Y squared is my perfect square. What was the base? Y. Okay. So what do I put first? X and X, and then Y and Y. What are the signs? Plus and what? Minus. Is that true? Let me give you guys a note here. If you had y squared minus x squared, how would we write that? Sorry, I guess you guys can't see. How do we write this one? Y plus x, y minus x. Good. Why do you put the y's first? Y squared was first. All right. Okay, pretty good. Number 19. Uh-oh, this is a hard one. 4x squared minus 4y squared. Now they're going to get super hard. Is that true? Well, let's think. I got a difference. And I also know x squared is a perfect square. Is 4y squared also a perfect square? Say yes. How do you know 4y squared is a perfect square? Oh, take a look. It's on my list. Is it on my list? No. Let's put it on the list. Take 2y and what? Square it. I get 2 squared y squared or 4y squared. 4y squared is now on the list as a perfect square. What was the base? 2y is the base. You guys okay with that? All right, 2y is my base. 4y squared is a perfect square. So, x and x, what's the base? 2y, 2y. What's the signs? Plus and minus. You factored. X plus 2y, x what? Minus 2y. Okay, you guys have factored out what we call, this is factoring the difference of perfect squares. Okay, let's do a few more. (21) 9x squared minus, what is that? Is that y squared? Okay. All right. We have a difference, don't we? And what else do we have? Is 9x squared a perfect square? It is. What about y squared? It is. So let's see. Do we have to go find 9x squared on our list? Do we have it? We sure do. 9x squared was a perfect square. What was the base? 3x. So make sure you generate this list so you can see what perfect squares are. All right, what goes first? 3x, 3x. And then what comes next? Y and y. What are the signs? Plus and minus. Good.
Only when it's negative, it's a plus or minus?
Yes. Here's the question here. What she really said or meant, right, is what do you mean by a negative? We mean this. only when you have a, right here, a what? A difference. So you need a difference there. Okay. 23, 16x squared minus 1. Okay, so I'm going to have here difference, and then I'm going to have what? Perfect square is 16x squared, by the way. 1's a perfect square. Let's double check. 16x squared on the list? No, 16y squared's on the list. Guess what I can do? Take 4x, square it. 4 squared x squared, I get. You guys know what I get here? 16x squared. That is a perfect square. What is the base, though? 4x. So my base is 4x here. 4x, 4x, 1, 1. What are your signs? Plus and what? Minus. You guys okay with that? Anybody have any questions on these here? Sure, pretty simple? Well, we didn't get to finish all the homework, I guess, right? Let's see. You want me to do the evens also? Well, you guys have to remember, you got to know that list. And if you know this list for 115, you'll know it for 125. So, you know, make sure you go home and reproduce that list on your own. Do it systemically. Start with 1, and then 2, and 3, up to 12, I guess.
Can we use it on the test?
That you have to memorize. You got to know those.
Can't write a little cheat sheet for the test?
You guys know why? Because in 125, we don't use calculators there. And you have to know that list in 125. So you want to get used to knowing it now. If you know it now, if you work on that, you know, you'll be able to do these in your sleep. And that's the real issue. So is 16x squared, first of all, we have a difference. Is 16x squared a perfect square? Yeah, we just did it. Is 25 a perfect square? Sure is. We've seen that before. What are the bases? 4x and 4x. Good. What about for 25? 5 and 5. So notice, for you to answer the bases, you don't have a calculator that does this the way we've been working with it. So you have to know that perfect square list and the bases, right? Okay, let's try 27. 27 is 4x squared minus 25. Do we have a difference? Is 4x squared a perfect square?
Yes.
Is 25 a perfect square?
Yes.
Okay. What are the bases? 2x, okay, and 5. Good. Good. Nice. 29. What is this? 81x squared minus 4 here. Okay. Well, I'm willing to bet. First of all, I know I have a difference, but I'm also willing to bet 81x squared is a perfect square.
Yes.
So is 4. You say, how do I know? Go back to the list that you've generated. What's the base for 81x squared? 9x, and then 9x. What about for 4? What's the base? 2 and 2. Good. Plus and minus. Look at that. 31, 49x squared minus 4. Okay. Now let's see. difference, perfect square, perfect square. What are the bases? 7x and 2. Good. Signs, plus and minus. Can I put minus and plus?
Yes.
Yes, that's fine. Minus and plus works okay too. Question?
I was like, is that a trick question?
Is that a trick question? No, it's not a trick actually. It's not at all. No one's tricking you. It's, let's see, 36x squared minus 49. All right, let's see. I have a difference. Do I have perfect squares? 36x squared and 49. Okay, what are my bases? 6x. For 49, what's the basis? 7. Good. Plus and minus. Yeah, because you know what happens is when you become more familiar with these perfect squares. And that's the secret, being familiar with a perfect square. The only way you really get familiar with it is if you generate that list over and over. And like I said, put it on the refrigerator. Put it on your, as the screen on your computer or your phone. And you get to know that list. You recognize perfect squares. And the benefit is then you're able to do these problems like 100x squared minus 9 now. You say, I do have a difference. And I do have a perfect square like 100x squared and 9. But what are the bases? What's the base? For 100, what's the base? 10, good. For x, what's the base? Or for x squared? X. So this is really 10x. For 9, you got a base of 3. And again, your signs are going to be plus and minus. This is not so bad. 37, we have 25x squared minus 4y squared. Here we go. Again, we have difference. Perfect square. Perfect square. So 25x squared, what's the base? 5x. Okay. For 4y squared, what's your base? 2y. Signs are plus and minus. $39 here. We have 16x squared minus 81. Let's double check. It looks like it's 81y squared. Okay. We have a difference. And then we have 16x squared and 81y squared, both perfect squares. So what's your base? 4x. Okay, what is your base for the next term? 9y. There you go. Plus and minus. We're almost done. 41. 49x squared minus y squared. We have a difference, and we have a perfect square, a perfect square. So what are the bases? 7x and y. Good. So now we have our signs. Plus, minus, and there we go. Okay.